Oh, welcome to 10.4 experimental design. This is the third to last video, I hope. Third to last video of the Integrated Mastery series. We have this is going to be a quick one as well, because it's just basically already repeating what you've already learned in science for the past 6 years, I hope. So this is we want a controlled experiment. What a controlled experiment is a fair experiment in science, right? An experiment where everything's kept fair. Um, there has to be a control, which is the group with nothing that happens to it. Or if you're testing something else, like as part of a question, it might be different. So, for example, people who have Tourette's, or like how many of the people who have coronavirus actually die, right? Or how many of the people who have severe coronavirus actually die. So you have a control of the people who have just any random just a random group of people who don't have the coronavirus, right? And then you have people who have mild coronavirus, maybe, and you'll have people who have severe coronavirus, or maybe you want to test the question that do people who have coronavirus survive longer than people who don't? Um, in that case, you would definitely take the control as the people who haven't had the coronavirus disease yet. So the control is the group with normal the control group is the group with normal circumstances, and the variable or the treatment group is the variable in the experiment. So you can have multiple treatment groups. You can have multiple levels of treatment groups. You can have multiple variables of treatment groups as well, right? Multiple variables of treatment groups. Uh, So, for example, maybe like the ice cream and the temperature of the day, something kind of like that, but it's an experiment. So there's always a control or variable. We're talking statistics, so it's mostly with people, right? And in order to make it, actually, no, okay. So sometimes they are randomized, right? Sometimes the process of selecting the groups are randomized, and in the randomized, this is a vocabulary. Randomized comparative experiment, the subjects are randomly assigned to the control group or the treatment group. Normally there's normally there's two treatment groups. Sometimes there's more than two treatment groups. So sometimes the subjects are assigned to more than two treatment groups, right? And that's just the nature of you know experiments. Sometimes you want to experiment with more than one stuff. Now, why do you want to randomize? Why would you want to randomize an experiment? Why would you want to randomize a experiment or an observational study? Actually, observational studies you can't really randomize them. But why would you randomize an experiment? Just think about it for a minute. Okay, you would randomize an experiment in order to keep it fair, right? So if you randomize the people in an experiment, you don't want to just put everyone who's, let's say, pregnancy. Okay, if you're doing a pregnancy experiment, um, and you want to see if people who have C sections um, are more prone to having or children who are born by C-sections are more prone to having sexually transmitted diseases than the ones who aren't born by C-section, or vice versa. You can have a control where there's a mix of those there's a mix of all ages of the or all ages and the amount of babies that the mother has born into one section, and then the same mix in the other section, in order to keep it fair, that if we want to find our if we want to find our experiment, if we want to find our result, and we want to make it as fair as possible, we have to have those different criteria as well. And there might be a third group, for example, both, right? Uh, the parents are both C-section and a regular birth. In that case, there wouldn't really be a control. The control would probably be there wouldn't really be a control. So you don't really have anything to compare it to. But if you just want to answer that question, then it would be an experiment. It would be a fair experiment, right? But what else? What else is needed to be done to an experiment to increase the validity of the experiment? Um, there's a lot of things that you can do. For example, you can take more trials, right? Think back to the dice experiment. We took more trials. Trials. What else can you do? You can also take trials of trials, or you can also take sets of trials. So, for example, you take five people on one day, and then you take 20 of them over 20 days. Or if you take 1,000 internet users and then you take them over a year, right? And then you rank them in a sort of bar graph, in a sort of normal distribution like this. The closer it is to that normal distribution, the more valid pretty much the more valid the experiment is, right? The standard deviation and stuff. Um, the closer it is to the bell curve, the more valid it is. Um, right? Some relationships just don't go as of the way of that bell curve. If it's completely randomized, sporadical, then you can't really say that it's going to be accurate or not. However, if it follows the trend, the better it follows that trend, the better the experiment is. Um, right? Sometimes nature is just not going for it, and sometimes they don't want to follow trends, or sometimes the trend doesn't work for all the trend doesn't work for everything. For example, quantum mechanics, right? It works for large objects, doesn't work for small objects, right? The classical physics. Um, yeah, I don't want to talk about that too much yet, but right, the so the trend, uh, you would want to find the trend in a statistic group, in order to have the good validity for the experiment, but it's not guaranteed that you will be able to find a trend where there might be an actual purposefully annoying loop, or like outlier in the trend, right? So let's answer a bunch of questions. Let's go. In exercise 3 and 4, determine whether it is a randomized comparative experiment or not. If it is, then do a treatment, explain the treatment, describe the treatment group, and the control group. Okay, so let's go. If it's not, describe whether, explain why not, and discuss if it's valid. Test a new drug for insomnia. A pharmaceutical company randomly divided 200 adult volunteers into two groups. One received a drug and one received a placebo. After 1 month, the adults who took the drug slept 18% longer, and uh, one who does not, the ones who don't experience no effect. So this is a randomized comparative experiment because it's randomly dividing 200 adult volunteers, and the treatment is insomnia, and the treatment group is the 100 is the group that received the drug, and the control groups is the one that received the placebo. And sometimes the placebo can be a treatment group. Um, Sometimes it really can, right? Well, just people who don't do it and people who receive the placebo. Sometimes the placebo could be a treatment group. It's a little bit hard to do that. It's a little bit hard to do an experiment like that, right? At a middle school, students can choose to drink milk or other beverages as long. 75 students would who chose milk were monitored for 1 year, as were 75 who chose other beverages. At the end of the year, students in the milk group had 25% fewer cavities than students in the other group. So I don't think this is valid, and there's a reason why it's not. I don't think it's valid. And the reason is one of the reasons were is that there's too many categories, right? 75 for just milk, which is one category, and then 75 you can have orange juice, you can have apple juice, you can have soda, which I don't think they sell at school. You can have just regular water, right? There's too many categories, so that's why it's not fair, right? And it's definitely not random. It's more of an observational study because you don't actually take the kids in, you observe them, right? It's an observational study. So the 25% of fewer cavities, uh, that's just kind of it's it's good. And well, no, it's not good. It suggests something else about the student that it does not that doesn't suggest the fact that milk actually, well, it depends on the conclusion, right? It depends on the conclusion. This isn't really the conclusion. This is not the conclusion. Um, if there's like an analysis for the result, that's more of a conclusion, right? This is a little bit bad. That's why I sometimes like do this to do the science part of this more than just the maths, because there's really no math in here. Um, so the students with 25% fewer cavities are actually uh well, good for them, and it's also not it's not really good. It's not a good conclusion, because they my conclusion would be that the 75 students who don't drink water from this part of piece of evidence, the 75 students who don't drink milk likely drink something else that causes their cavities to be causes their cavities to grow, like apple juice, orange juice, or soda, because they have a lot of sugar in them normally. Okay, next, number 5 and 6 in exercise 5 and 6. Describe and correct the error. The company's researchers want to study the effect of adding shea butter to a hair conditioner. They monitor the hair quality of 30 random selected customers in the regular and 30 random under the new shea customers. New shea butter conditioner. Control groups individuals who do not use either of the containers. That's wrong. That's not wrong. That's not right. And there's only two groups in here, so the correct answer would obviously be the 30 conditioners who uses the regular conditioner, because there's a bunch of conditioners and they want to know if their conditioner is better than another conditioner, not not their conditioner being better than just um, someone who doesn't use conditioners. Because obviously conditioners are gonna make your hair. I don't even know what conditioners do, but they're gonna make your hair better some way. Right? They're gonna condition your hair. So it's really just it's not it's not a control group. It's just the population basically. So the study is an observational study. They monitor the hair quality of 30 randomly selected customers. Um, it is not an observational study for one reason, and the one reason is they gave the is the customers knew that they were going to be doing the knew that they were going to be using the conditioners. That's the only reason why it's not an observational study. If they didn't know, it would have been an observational study. But the regular conditioner is there's only one regular conditioner, because it's the regular conditioner, one regular conditioner. So we could tell that all of the customers who were using that one regular conditioner were most likely didn't all choose that just one conditioner. And if they did all choose it, it wouldn't have been randomized. It wouldn't have been random. Therefore, it's an experiment, not an observational study. It's a little complicated. Exercises 7 through 10 explain whether the research topic is best through an experiment or observational study. Okay, so a researcher wants to compare the body mass index of smokers and non-smokers. Observational study, because people who don't smoke don't want to smoke, right? Restaurant chef wants to know which pasta sauce recipe is preferred by more diners. Observational study as well. We can't get the people to I'm not gonna do not gonna do this. you can't get the people to want to. You can't just get the people to want to choose each pasta sauce. You don't want this person to. You have to eat this pasta sauce, or else I'll put you in jail. No, no, right? It's just not. It's not feasible. A farmer wants to know whether a new fertilizer affects the weight of a fruit produced by strawberry plants. Experiment, not an observational study. Plants can't have their own fertilizers. Plants can't just reach out and get the fertilizers by themselves. That's weird. 10. You want to know whether homes that are close to parks or schools have higher property values. Observational study. Because you can't force people to move homes. That's why. Number 11. Company wants to test whether a nutritional supplement has an adverse effect on an athlete's heart rate while exercising. Identify a potential problem, if any, with each experimental design, and then describe how you can improve it. Company randomly selects 250. Half of them receive the supplement, and their heart rates are monitored while they run on a treadmill. Other half are given a placebo, and their heart rates are monitored while they lift weights. Automatic red flag right here. Lift weights and on a treadmill are not the same variable. We have two variables. That's not allowed in an experiment. I said they are allowed, but that's if you do it like this kind of thing, right? Where you have treadmill, and then you have lift, and then you have lift weight, where you give it to those athletes, and you force both groups to do the two things. You can't just force one group to do one and one to do the other. That's not a valid experiment. You have to force both groups to do the two things. Then you would right. Then you would be able to make it fairer, right? So if you force both groups to do both of the exercises, then that would be a better experimental design. The company selects 1,000 athletes this time. The athletes are divided into two groups based on age. Automatic flaw right there. Within each age group, not an automatic flaw. See, if I wouldn't have read it again, if I wouldn't have read it, I would have not seen that if it's within each age group. The athletes are randomly assigned to receive the supplement or the placebo, and then they are monitored while they run on the treadmill. And then once you read this final sentence, you can finally conclude that this is a flaw, and the reason is one of the groups are less. Well, one of the groups are younger, so obviously they're going to be more active, and then the other group are another group is older, or another group is older. Obviously, they're going to be less active. But the fact that there was no significant difference in the increase of the heart rates between the two groups, that's pretty impressive. I'm not gonna lie, right? So the old people were the older kids were probably active, more active, or the older athletes. 16, final question. We're not doing 17. To test the effect of political advertisements have on voter preferences, a researcher selects 400 potential voters and randomly divides into two groups. Right, circle graphs or the pie charts show the results of the study. So, is this study a randomized comparative experiment? And explain. Well, random. So yes, it is a randomized experiment because they are chosen at random. Describe the treatment. The treatment is TV with ads. Right. So TV with ads. People who vote. No, people. TV with ads. I don't know what I'm saying. I'm sorry. So if you watch the TV with ads, then that's the political. That's the treatment, right? That's the brand. The treatment. And the C is, can you conclude that the political advertisements were effective? And my answer is yes, they were effective. That's a plus 6% increase. Margin of error around, I'd say, plus or minus 1%, right? Or plus or minus 5%. Plus or minus 5%. right? That's still a high increase. That's from 1 to 11% increase. So because it's from 1 to 11%, there's at least a small amount of increase for watching the TV with ads for candidate B. And I'm gonna tell you how to calculate the margin of error in the next section, which it will be the final slides that I'll make for this in the 10.5. So it will be 1 to 11%. So then we will have an increase, right? That's great. We have an increase. But what's the result of the thing, right? Well, we have 15% of undecided. Wait, no. First of all, before the undecided voters, we have 43% of candidate A, 45% of candidate B. After watching the ads, they probably well, the people who watch the ads are probably more fond of candidate A. I don't blame them. Candidate C, pretty much the same thing as well. Candidate B, increase in 6%, and the undecided decrease in 7%. Right, so the undecided decrease in 7%. If I put plus or minus 5%, which is the margin of error, or the estimated, it'll be minus 2 to 12%. So there's definitely a decrease in the amount of undecided and an increase in the amount of candidate B. So therefore, the undecided people would want to vote for candidate B if we show them the TV with ads for the candidate B to the undecided voters, right? So everyone else kind of useless. The undecided are the way to go, right? And that's going to be it for today's lesson. I'll see you next time for making inferences.